Hello everyone, in this presentation we are going to discuss about the rotary encoder part of this mobile robot. So this is the mobile robot with the wheel radius of 6 cm as we see here, and when you look at the calculation you can understand very clearly. If you see here, the radius of the wheel is 6 cm and the circumference, if you find the circumference, we will get 38 cm is your wheel circumference, meaning one revolution of the wheel will travel 38 centimeters or 380 millimeter. So in this robot, if you see, there is a encoder connected to it. This encoder specification is discussed in the previous video, so but quickly I will refresh about it. This is the encoder which will help us to measure the distance traveled by the robot, speed of the robot, direction of travel of the robot, everything can be measured. That is what we are going to experiment it today. So when you look at the encoder specifications, if you see, so this is the encoder specifications. The arrangement is something like this. So the encoder is connected to the motor is connected to the gearbox, and the wheel is connected to the gearbox. So the gearbox ratio is 19:1 according to the encoder specifications. So 7 pulses per revolution the encoder will produce, but the gearbox ratio is 19, means 19 into 7, 133 pulses per revolution of the wheel. That means if every wheel rotates one revolution, means it will produce 133 pulses per revolution. If so, for 360 degree of revolution, 133 pulses will produced. So approximately for every 3 degree rotation, it will produce 1 pulse. For every 3 degree encoder pulse, 3 degree of rotation, encoder will produce 1 pulse. That is what the idea here. So by having this calculation as a reference, when you look at this, when the wheel turns 90 degree, when the wheel turns 90 degree, for every 3 degree it will produce 1 pulse, means for 90 degree it will produce 30 pulses. So 90 degree turn of the wheel produces 30 pulses. So if so, 90 degree turn will make the robot to travel. Every 3 mm movement, robot will produce 1 pulse. So 30 such pulses will become 90 millimeter, which is nothing but 9 centimeters. So 90 degree turn of the wheel will travel 9 centimeter. That is what. So for 9 centimeter distance, encoder will produce 30 pulses. That is what we are going to see here. Here you can see the measurement shown here. Here this marking is 0 degree, means this marking is 90 degree. So this 90 degree turn will make the robot to move 9 centimeters here. As we see here, it's very simple. So the 90 degree angle will make 9 centimeter movement. That is what we are going to experiment it here. So when I make a 90 degree movement, so I am going to make a 90 degree movement forward, then I am going to make a 90 degree movement reverse. I am going to make a forward 90 degree movement and the reverse 90 degree movement. Both forward and the reverse 90 degree movement will help us to get the pulses from the encoder. So we are getting the 2 pattern of pulses from the encoder if we see. So one pulses is A pulse, another pulses is B pulse. Why we are getting 2 pulses? We do not know in which direction it rotates. So the presence of the 2 pulses help us to measure the direction of rotation. So how to measure the direction of rotation means, when you look at the rising edge, yellow waveform goes up first, then the green waveform goes up next. Always you see, yellow waveform goes up first, then green waveform goes up next. Yellow waveform goes up first, then green waveform goes up first next. Again if you see, and yellow waveform goes up first, then green waveform goes up next. Yellow waveform goes up first, green waveform goes up pulse next. Like this if it goes on. So because we are rotated 90 degree, 30 such pulses comes. So the main objective of this discussion is, when the yellow waveform goes up first, then green waveform goes up next, means this is one direction of rotation. When you look at the other case, if you see here, in the next pattern, in this pattern if you see, in all this pattern you can see green waveform goes up first, then yellow waveform goes up next. You can see green waveform goes up first, then yellow waveform goes up next. Here you can see green waveform goes up first, then yellow waveform goes up next. So in this pattern, green waveform goes up first, then yellow waveform goes up next. This justifies the direction of rotation in other direction. So only the 2 pulses from the encoder help us to identify the direction of rotation. In the clockwise direction you will get like this. When we rotate in the anti-clockwise direction, you will get another pattern of pulses. You can see like this. Forward one pattern, reverse one pattern. Once again, if you see, waveform again if you see here, so forward one pattern of pulses, reverse one pattern of pulses. Once again, if you see, forward, reverse, forward, reverse, forward, reverse, forward, reverse. You can see forward, reverse, forward, reverse. In this wheel, we are expecting 9 centimeter movement. For 9 centimeter movement, as per the calculations, we are supposed to get 30 pulses. Now you can see 0 degree. Now 9 centimeter movement forward, 9 centimeter movement reverse. And if we are stopping it, and if we are about to check 30 pulses here, if we see. So if you want to count, means what? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. 30 pulses we are getting in the forward direction. And again, approximately you see 30 pulses we are getting in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 pulses we are getting in the reverse direction. So this is the reverse direction where you can see yellow goes up first, then green goes up next. Yellow goes up first, then green goes up next. Yellow goes up means it is reverse. When green goes up means first means it is forward. That is also you can reverse. Very well you can understand. When green goes up first means it is forward. So this is how all the rotary encoders are helping the mobile robot to measure the distance travel, speed of the travel, direction of rotation, etc. From this experiment we have understood how the rotary encoder is helping us in finding the distance traveled as well as the speed as well as the direction of rotation. By having this as a reference, we have to program the mobile robot to travel forward, reverse, left or right. This is the basic principle of mobile robot, looking at the encoder readings to measure the both forward and reverse direction. Thank you.